Hi, so please introduce yourself.
Well, I'm Phil Surman from the UK. I currently work in Shenzhen on 3D glasses, free 3D displays.
And this is the Southern University of Science and Technology.
Yep, Sussex. Yep.
Is it a very high-tech place?
Oh yeah.
So what's the latest in the waveguides that you're working on here?
It's a meta surface. It doesn't have colour aberrations. Efficient, potentially cheap. Works very well.
Is there a problem with the waveguides and having color aberrations?
Well, there is with a normal diffractive waveguide, but being a meta surface, a single structure is optimised for 3 primary colours. We use a laser projector, which is narrow wavelength.
What is a meta surface?
It's a structure where the features are in the order of nanometers. When you consider that a wavelength, say green light, is around 500-600 nanometers, you're talking about it's working a different way to a normal diffractive surface. I don't personally understand exactly how it works.
It's in a nanoscale. Something is happening.
Way below the wavelength of light.
And what do you talk about here? Waveguide type AR.
Yep. Which is going to be the way of the future. It's not a big clunky thing on your head.
Yeah.
It's glasses.
Like what you're wearing right now.
Eyeglasses.
Is it active? Your AR? You don't have it active right now, no?
Oh no, this is just glasses.
But it should look like that, right?
This is the idea, yes. I mean, we don't want these big, heavy things on the head. We want glasses form factor. Well, these won't allow it. They're too big. These prisms are heavy and thick. So the future is waveguides. Whatever Apple are doing, the future is waveguides.
Waveguides is the future.
Yep.
AR is the future.
Yep.
And there's been some amazing demos of micro LED based AR, maybe micro OLED or some other solutions would be there.
Yep.
But they all need a waveguide.
Well, to be in a practical form, yeah.
And so how do you make the best waveguide?
I'll have it made for us, and it's at the moment it's quite an expensive process, but it's just, potentially cheap. Apparently it can be done on roll-to-roll eventually. So it's quite exciting.
You have a roll right here.
No, it's just a poster came in that. The roll-to-roll process.
Yeah.
Which is so we could,
you can make kilometers of it.
Yeah.
And it will be quick and precise somehow in a nanoscale.
Yeah.
So it says conventional coupler, meta-surface coupler, and there's something happening, right? Because it's different.
Dispersion, chromatic dispersion, parallel.
Nice. Are there prototypes of this?
This is the only one so far.
So there's one that's being demonstrated right here.
Yep.
And what does it show?
Shows a parrot, which is the virtual image, overlaid over, as that chap from Apple just said, obviously over the real world, because these are out of focus. The parrot will be in focus because that's the way it works. So everything, like a lot of waveguides, is focused at infinity. So this is obviously real world here, and virtual parrot overlaid.
Nice, because it's I guess it's a big challenge in AR to have the focus be in the right place next to the people. Like there should be a bubble above you that gives more information.
Yes, and I'm not sure how it fits in with this. I have to admit that we might need some extra active device.
That could be maybe an eye tracker and also smart AI algorithms that figure out what is in front of the person and puts it next to them. But when you don't have these kind of what do you call it, aberrations and
well, if you're going to use a waveguide, any waveguide of this type is a fundamental issue, if you like, with any, whether it's the old school geometrical waveguide or whatever. Without any additional optics, it's not going to give you the accommodation.
It's interesting how these zigzags happen. I'm like interested to understand how
That's
that
just
works.
ordinary total internal refraction. That is reflection.
That's just how it works.
Nothing special.
Nothing special about that.
Oh no, I mean everything does that. I mean the back of your television, back of your monitor has got this. That's why they're so thin. You guide the light up from the white LEDs at the bottom, up this guide, less than a millimetre thick. I never thought why your laptop is so thin. Very clever optics go into it. So that is a pretty standard technique.
All right. But then you add all this other stuff and the way
This
you...
is the thing, yeah, this is a standard configuration with an input coupler from your projection engine, output coupler to the eye, and it's conducted, if you like, through this total internal reflection light guide. So this layout is pretty standard. It's the technology right down at nanoscale that is the unique part.
And there you describe how the prototype is made?
Yes, I don't, in all honesty, I'm not quite sure what this
Stuff happens.
shows. Yeah, I'm not sure.
There's a nano lab where you work? There's like a nanotechnology
Not
experts?
really, it's a 3D lab. My speciality is glasses free 3D. But this is a student working away in one corner. He works sort of all his waking hours and has developed this over the last couple of years.
And the glasses free 3D have really had a success at this Display Week show. The entrance...
I'm giving a talk tomorrow on it. So, and what we're showing is very conventional. What I'm talking about tomorrow. And that's very popular now, glasses free head track 3D.
My favorite screen in the world is the BOE 32-inch light field head tracking glasses free 3D.
I'm talking tomorrow about the one we've built, but it's only 8K, because all we could buy at the time. But it's exactly the same system.
It's 32-inch?
32-inch, but it's 8K.
8K, yeah? That's what they use at BOE, right?
So there's a 16K.
Oh, they have the they have the big 16K.
They make it, so they've got the advantage.
Yeah.
So tomorrow we're talking about, we've got some 80-degree field of view, so you can look at it at that viewing distance. You can look at it over a width that's greater than the viewing distance. It really is. So we have exactly the same principle.
And what I wonder about the 3D glasses free, because there's been a lot of talk for many years about 3D. They tried with the glasses and all this stuff, and it was like blur. It was not so great. But when I see the latest stuff that they're showing, it's so sharp. I guess you don't get tired of looking at it,
16K.
right?
16K. The other thing is because it's tracked, you can compress all the views down, so you get a greater
Higher
depth.
resolution.
Yeah, you get greater what's called angular resolution. So by tracking it, you can squeeze all the views, and that gives you greater depth. And then this sweet spot then follows your head as you move your head.
How do they compress all the views? I don't understand this.
We just choose different focal length. It's as simple as choosing a longer focal length lens in the lenticular array. So there's nothing magic about it.
Because as I understand, a light field display has all these different specific amount of views. And it could be 64 or 16 or something.
With our mapping, you can dial in the number of views you want. If it's too low, now on the big one, if you look at it, I've got it captured here. As you move your head, something sticks out of the screen, goes like that. What we do, if we put in more views, it's smooth. So we've got completely sort of flexible software, so we can overcome this sort of discontinuous motion parallax.
And at the BOE booth, I saw the 16K, but I prefer the 32-inch 8K that they were showing off. It seems much more sharp.
Yeah.
And the effect looks better. It looks like something that's the sharpest glasses 3 I've ever seen.
Because they're tracking.
Because they're tracking. Maybe on the big one they're not tracking.
They're not tracking, no.
They're just providing all the angles. So actually there's higher resolution on the small one.
Yeah, I've checked it, and I think the views, it was very hard to tell as people walking past. But it's because it's not tracked that it's not as sharp.
Because they don't compress the views.
That's right, yeah.
All right. If they did compress the views, it could be amazing.
But that gives you more depth. So the depth isn't that good on that big display. I don't know how you feel, but it's...
Yeah, I prefer the smaller one. The 32-inch, that's the one. That's the one I think is amazing.
We built this about 2 years ago, but we've never demonstrated it. I thought it's time we did.
Because I saw the BOE showed a 32-inch 8K last year, and I was wondering, you're just showing the same one. But the guy told me, no, we did a bunch of improvements, but he didn't want to tell me what they improved.
Yeah.
What do you think they improved?
I don't know. But the fact it's tracked, that is the big thing. Now, one problem, this is why I want to go forward, it's only single user. Because you track a sweet spot, but when you have them on that type of display, all your sweet spots form a regular pattern, so it'll work for one person, but of course it's moving for me. But yes, someone else might see 3D, but it's actually only tracking one person. So
that's how it is, right?
Yeah, and this is why I want to go forward, and that is quite difficult. Taking a couple of patents out, and then you've got to start, it starts getting complex, you have to start playing around with the backlight. So we have to dismantle. I mean, I've broken so many LCDs by taking the backlight off. It is a whole level of difficulty greater, but this is what I'm really interested in.
Oh, nice. So you could, when you do the eye tracking, you can do more than just focus the angles. You can also focus the backlight in a different way.
This is what I plan to do. Also, you can do temporal multiplexing. Now, we've run LCDs reliably up to about 200 hertz. So what you do is have a sweet spot for one person, and then the next period of time you have a sweet spot for the next person, so do them sequentially.
And they would not see that it's switching. Nobody would see the switch.
Well, that's something you have to be careful of. There's motion artifacts. They might be flickering. You might, corner of your eye, you might...
It'd be hard with the camera to record it, maybe, because if it's not the right frequency or something.
So this is a potential problem. But then it's same shutter glasses, the big 3D displays that you get, like if you look away from it, you'll see the flickering because of the critical flicker frequency.
What would be awesome is that this 32-inch 8K glasses-free 3D display has a mode that's 3D, but when it's off, it doesn't look any of the quality of a regular non-3D display.
Because they have a lens in front of them which is fixed. Now that lens has to be a lot wider than the pixels to gather lots of rays, because you've got a thing called angular resolution. So you've got a trade-off.
So the trade-off has to stay. But is there a way to maybe turn off the 3D effect?
Well, that's something. If you've got a lens, your resolution in the horizontal direction is the same as the pitch of the lens. There's no two ways around that.
So a 3D display has to remain 3D?
Oh no, you can switch it. I mean, Philips did this 20 years ago. So you can have a liquid crystal layer that switches it on and off.
All right. So AR, how big is it going to be? How soon is it coming?
Well, I'm a bit... I've been a bit cynical about it. I was saying it's been the display of the future for many years. There's a lot of hype. And you look at, in this whole of this conference, there's 7 presentations on 3D and about 100 on AR.
So it could happen fast.
Well, yeah, but there is a lot of hype about it, and I've seen this for many years. So, and I tried the Apple one the other day, and I didn't like it particularly.
Yeah.
The software was beautiful, but
the hardware needs to catch up.
Yeah, latency. Are you still?
Yeah.
As I moved my head, it took time to settle. And I personally I don't like a big thing like that on my head. That's a personal preference, but I think it's got to come. This is to the future. You take this horrible, great thing that's stuck on your head, and you give it the glasses.
It needs to be like what you're wearing.
Yeah.
That's it.
Well, that's easier said than done, but that is
Next
yes.
year. Next year, I want.
Holy Grail. Well, hopefully, that's what everyone's working on. There's a lot of effort, but this is what everyone's hoping, yeah.